Hi, this is Raoult here. Now in this presentation is all about the distillation operation. Let's start the presentation. Distillation is a unit operation in which the constituents of a liquid mixture are separated using thermal energy. Basically, the difference in vapor pressures of different constituent at the same temperature is responsible for such a separation. The unit operation is also termed as fractional distillation. Here, this flow diagram all about the distillation process. Example of distillation. Gasoline processing of coal. Kerosene. Fuel oils. The refining of oil. The catalytic cracking. Purification of ethanol. Boiling point diagram. It is used to show the equilibrium vapor and liquid phase compositions, that is Y and X, change with temperature. Here in this figure, about the mixture handled consist of benzene, a more volatile component, and toluene, a less volatile, heavier component. The composition of mixture is plotted as abscissa in terms of the mole fraction of the more volatile component, and temperature of the mixture is plotted as ordinate. In the process of boiling, the mixture boils over a temperature range from B to K, from the bubble point to the dew point, so the term boiling point has no meaning for the mixture and the correct term is the bubble point. Bubble point is the temperature at which a liquid mixture of a given composition starts to vaporize as the temperature is increased. The liquid represented by any point on the lower curve is at its bubble point, and hence the lower curve is called as the saturated liquid curve or the bubble point temperature curve T versus X. The condensation starts at any point on the upper curve, and hence the upper curve is called as the saturation vapor curve or the dew point temperature curve T versus Y. For distillation calculations, the equilibrium vapor-liquid composition data can also be plotted in this figure, wherein the vapor phase composition Y is plotted as an ordinate and the liquid phase composition X is plotted. Raoult's law. It is commonly used for predicting the vapor-liquid equilibrium for an ideal solution in equilibrium with an ideal gas mixture from the pure component vapor pressure data. It states that the equilibrium partial pressure of a constituent component in a solution at a given temperature in the liquid phase. Thus the binary, two-component, system, if Pa is the equilibrium partial pressure of A, Pa0 is the vapor pressure of A in the pure state and Xa is the mole fraction of A in the liquid phase. These are the equations to completely understanding the Raoult's law. Now, jump to the Dalton's law. It states that the total pressure exerted by a gas or vapor mixture is equal to the sum of the partial pressure of the component present in it. Thus, it expresses the additive nature of the partial pressure. Partial pressure is equal to the mole fraction and total pressure. Knowing the vapor pressure of component A, more volatile component, and B at various values of temperatures, X, Y, data can be generated for an ideal solution as follows. Knowing Xa, the corresponding equilibrium value of the vapor phase concentration, Ya, is obtained with the help of the equation. Volatility of A is defined as the ratio of the partial pressure of A to the mole fraction of A in the liquid phase. The relative volatility of a component A with respect to a component B is the ratio of the volatility of A, the mole volatile component, to the volatility of B. It is also known as the volatility of A with respect of B and is denoted by the symbol alpha AB. Thus, the relative volatility is the ratio of the concentration ratio as A to B in the vapor phase to that in the liquid phase. From the equation alpha for a given binary system X, Y data, equilibrium data, can be generated by taking X equals 0, 0.1, to 1 and evaluating the corresponding values of Y equilibrium vapor phase composition. For an ideal system, volatility is equal to the vapor pressure of the pure component. The relative volatility of A with respect to B is also defined as the ratio of the vapor pressure of A to the vapor pressure of B at the same temperature. In methods of distillation, the liquid mixture to be separated is heated to create a vapor. The vapor formed is condensed in a condenser and withdrawn as product. As there is no reflux, products of relatively low purities are obtained. It is the method of separation is not effective. Many such unites are used, especially where the components to be separated have widely different boiling points and methods giving sharp separations are not necessary. The simple distillation technique: a known quantity of a liquid mixture is charged into a jacketed kettle or still. The jacket is provided for heating mass in the still with the help of a heating medium such as steam. In early stage of distillation, the vapor so the liquid in the still becomes lean with respect to the more volatile component. Product from such units can be length of distillation. Let's continue with the distillation. Flash or equilibrium distillation. The material balance of the more volatile component is with the slope equal to -1 F by F and an intercept equal to XF by F. Flash distillation is normally carries out in a component manner. In this method, a liquid mixture is partially vaporized, the vapor and liquid are allowed to attain equilibrium by providing a sufficient contact time and finally withdrawn separately. Feed is heated in a tubular heat exchanger. Flash distillation is commonly used in petroleum industry, handling multi-component system in the pipe. Rectification binary systems. It is possible to get almost pure product by this method. The enrichment of the vapor stream as it passes through the column in contact with reflux is termed as rectification. Fractionating column. The fractionating column or fractionator consists of a cylindrical shell divided into sections by a series of perforated trays. A reboiler and a condenser, this column divided into two sections, rectifying and stripping sections. The section above the feed plate or tray is called the rectifying section, wherein the vapor is washed to remove the less volatile component with the liquid returned to the column from the top known as reflux. The portion below the feed plate including the feed plate is called the stripping section wherein the liquid is stripped off more volatile component by rising vapor. Perforated trays are nothing but gas-liquid contacting devices on which gas, vapor and liquid are brought into intimate contact for mass transfer to occur. Vapors are generated in a reboiler and are fed to the bottom of the column. The liquid removed from the fractionator rich in the less volatile component is called the bottom's product. Batch distillation is used extensively in small-scale production units where the same piece of equipment is used for many different mixtures and where small quantities of the liquid mixture are to be handled. It is useful when more than one product is to be obtained and when the liquid mixture to be separated are high in solid content, for example tar. The specific quantity of a liquid mixture is charged to a reboiler. Heating is applied. Vapor generated flow upward through a fractionating column and a part of the liquid from a condenser runs down the column as reflux. The entire fractionating column acts as an enriching section. Steam distillation. The method generates organic solvent-free products. There is no need for subsequent separation steps. It has a large capacity for processing at the industrial scale. The equipment is inexpensive. There is extensive know-how available for this technology. On the other hand, the main drawbacks of this technology include 1. Sensitive compounds could be thermally degraded and/or hydrolyzed. 2. Very long extraction times, 1 to 5 hours, are needed, and 3. High energy consumption. Various plates used for phase contacting are tray spacing 300 nanometers, diameter 1.5 meters, 450 or 600 millimeters is used for tray access. Bubble cap plate or tray. Sieve plates. Size 3 to 12 millimeters and holes range 5 to 15% of the plate area. Valve plates. Metal dicks, 38 mm diameter, cost 20% high from sieve plates. Liquid flow patterns over tray or plate. Depends upon liquid to gas flow ratio. Cross flow. Provides good length of liquid path. Reverse flow. Provides a very long liquid path for low liquid to gas ratio. Split flow. Especially suitable for handling high liquid to gas ratio. These are all figures to analyze the flow patterns. Now I am going to talk about the Downcomer and weir. Downcomer and weir. Passage for liquid flow from a plate above to the plate below. 1. Liquid flow from a plate above to the plate below. 2. Weir is used for maintaining a certain depth of liquid on each plate needed for gas contacting. 3. Weir length 60 to 80% of the tower diameter used. As a gas bubbles through a pool of liquid on a plate, a large amount of turbulence is set up, and liquid particles can be entrained by the rising gas. Carryover of liquid particles by the rising gas from a plate below to the plate above. Packed column are useful for distillation, especially whenever we are dealing with heat-sensitive materials.
Packings are usually cheaper than plates for columns less than 600 mm diameter.
A packed column consists of a cylindrical shell containing a support plate and a liquid distributor. The cylindrical shell is filled with some sort of packings that rest on the support plate. The liquid distributor is designed for effective irrigation of the packings. Thanks for watching this video. I hope you subscribe my channel and share your comment and like the video.